In this video, we will see how to determine the period mainly, and also some other characteristics of tangent and cotangent functions. Please note that in this section, we are not going to look at the graphs of tangent or cotangent functions. Instead, we are going to just look at the given equation, and if necessary, it will be modified to fit the generic equation, and then from there, we are going to determine the period and also some other characteristics such as the phase shift, reflection, and the vertical shift. Let me first write down the generic equation. This is how I'm going to write down the generic equation. A times the function, whether it is the tangent function or the cotangent function, which I will write simply as ratio, where this ratio stands for either the tangent function or the cotangent function. Also, please note that when you write ratio, the tangent or the cotangent function, if there is a negative symbol, that has to be read alongside the tangent or the cotangent function, not with A, because A is still called the amplitude, even though amplitude doesn't make much sense when it comes to tangent and cotangent functions. And then we open brackets, write a B, open parenthesis, x minus c, close parenthesis, close the bracket, plus D. Now we will define these terms one more time real quick. A is the amplitude. However, the amplitude doesn't make much sense when it comes to tangent or the cotangent functions. Therefore, many people usually do not define an amplitude for the tangent or the cotangent functions. The only importance of the A is when the angle is going to be equal to 45 degrees. Because if the angle is equal to 45 degrees, we know that the tangent 45 degrees is equal to 1. Also, the cotangent 45 degrees is equal to 1. And that same characteristic holds true even if you add or subtract an integer multiple of 180 degrees to that 45 degrees. Apart from that, the amplitude A is not going to be so helpful for this function, because you know that both tangent and cotangent curves exist from negative infinity to positive infinity. Therefore, let me go ahead and simply erase the definition of the amplitude for tangent and cotangent functions. You can simply ignore the idea of amplitude when it comes to tangent and cotangent functions. Then we have the ratio. What we mean by ratio is whether the function is a tangent function or a cotangent function. Also, please do not forget to include whether it is a plus or a minus tangent function, whether it is a plus or a minus cotangent function. In case if whatever the function uses has that negative symbol, which means there is reflection. If the function is a positive function, there is no reflection. Next, we look at B. B alone is not super important. What we need is the period. Period tau is equal to pi over B. That is very important. Because of that difference only, I wrote down this part as ratio rather than trig, because in the sinusoidal curves, how did we determine the period? In the sinusoidal curves, which means in sine functions and cosine functions, we determined the period by using the equation 2 pi over b. But here, for the tangent and cotangent functions, the period is pi over b. We have a c right here. C is, as usual, the phase shift. And finally, we have a D right here. D is the vertical shift. Vertical shift is where the axis is going to be found. All right, now we will do a couple of examples. Here's your first example. Determine the period and the other characteristics, such as the phase shift, vertical shift, whether there is reflection or not, for the function tangent 2x. That's a simple function. Let me first write down the generic equation. So the generic equation is A ratio brackets B x minus c close brackets plus D. I need to rewrite this function to look like the generic equation. I will write that function as 1 times, it's a tangent function, therefore tan, open brackets, 2 times x minus 0, close brackets, plus 0. Now I can quite easily compare this equation, which exactly is the given function tangent 2x, with the generic equation and identify a, b, c, and d. So what should be your a? A is equal to 1. A is not so important when it comes to tangent and cotangent graphs. Therefore, I will just leave it as it is. What we need next is the value of b. B is equal to 2. B is equal to 2 means what should be the period? The period tau is defined for tangent and cotangent functions as pi over b. Therefore, it should be pi over 2. We found the period for this function. What's the phase shift? The phase shift is given by c. C is equal to 0, which means there's no phase shift. How about the vertical shift? D is equal to 0, which means there's no vertical shift either. How about reflection? This tangent curve is a positive tangent curve. There is no negative symbol associated with the tangent function used in the equation, which means this graph has no reflection either. Alright, now we will do another example. Here is your example number 2. Determine the period and the other characteristics of -3 cotangent 3 pi x over 4 minus pi over 8, close brackets, plus 10. Now I need to determine the period, whether there is a phase shift, whether there is a vertical shift, whether there is reflection in this function. I will compare it with the generic equation. So here's the generic equation again. A times ratio brackets b times x minus c, close brackets, plus d. This is what I'm going to do. We said a should always be positive. Therefore, I cannot put this negative symbol with the 3. That negative symbol should be read with the function cotangent. Therefore, I'm going to just write it as a 3 times a negative cotangent function. I will open brackets. I need x by itself and factor out the rest. Therefore, I'm going to factor out 3 pi over 4. Open parenthesis, the first term is an x. Then we have this negative symbol, wrote down that negative symbol, and then I need to determine the value of c. Right here I have a pi over 8 term. What I factored out was 3 pi over 4. Then how do I determine the value of c? In order to determine the value of c, I need to divide pi over 8 by the term that I already factored out, which is 3 pi over 4. When I simplify this, this is going to be equal to pi over 8 times 4 over 3 pi. We can nicely simplify that. The pi's will be cancelled. 4 times 1, 4 times 2. This simplifies to be equal to 1/6. Therefore, the c that should be appeared right here is equal to 1/6. Close parenthesis, close brackets, close big curly brackets, plus d. I have a plus 10. So let me write it as it is. Now we can compare this equation with the generic equation and determine all the things that we need. A is equal to 3, but a is not so important for this function also because this is a cotangent function. There's this negative symbol that is important because that negative symbol indicates that there is reflection. And then how about the value of b? B is equal to the value right here, 3 pi over 4. Like we said earlier, the value of b itself is not so important. What we need is the period. So the period calculation is the most important part. Tau is equal to, it's pi over b for the tangent and cotangent functions. Please don't use 2 pi over b. 2 pi over b is only for sine functions and cosine functions. For the tangent and cotangent functions, the period is equal to pi over b. b in this case is equal to 3 pi over 4. So how would you simplify this? In order to simplify that, you need to multiply both top and bottom by 4. Then in the denominator, the two 4's will be cancelled. From the numerator and the denominator, the pi's will also be cancelled. Then this is going to be equal to 4/3. So we figured that the period should be equal to 4/3. The next question is there a phase shift? Of course, c is the phase shift. From this equation, c is equal to 1/6. That means there is a phase shift of 1/6, or in other words, this function is shifted to the right by 1/6. Is there a vertical shift? The vertical shift is given by the value of d. d is equal to 10 in this problem. That means the given function has been shifted 10 units up along the y-axis. So that's how we determine those characteristics. We will do one more simple example. Here's your third example. Let's say you need to determine the period and the other characteristics of tangent 2x plus pi over 4. Once again, you need to rewrite this equation to look like the generic equation. So the generic equation is a tangent b x minus c plus d. There are few things that I have to do with this simple function given here. In the middle, I have a plus sign. In the generic equation, I have a negative sign. Therefore, I have to keep that in mind when I convert that given tangent function into the generic form. Secondly, I need to factor out the 2 so that x term can be isolated. This can be written as 1 times tangent, open brackets. Let me factor out 2. When I factor out 2, in the parenthesis, of course, the first term is an x. And how about factoring out 2 from pi over 4? To determine that value, I need to divide pi over 4 by 2, which means pi over 4 times 1/2. This is equal to pi over 8. Therefore, I know that the term that should be written here is going to be equal to pi over 8. So let me write down that as a pi over 8. But please note that the symbol right here is a plus sign. But what I need is a minus sign. Therefore, I need to write down that pi over 8 as minus negative pi over 8. That way I have gotten the plus sign. Then I will close the brackets, and there's no d, so I will just write it as a plus 0. Now we can figure out all the components. We know a is equal to 1, but I'm not interested in that amplitude. What I need is the value of b, which is equal to 2. In fact, it is not the b that I need the period. Period for the tangent function is defined as pi over b. b is equal to 2. Therefore, the period is going to be equal to pi over 2. Then, is there a reflection in this graph? No reflection, because there is no negative symbol prior to the tangent function. How about the phase shift? We have a phase shift. C is equal to negative pi over 8, which indicates that we have a phase shift of pi over 8 to the left. How about a vertical shift? The vertical shift is given by d, and that d is equal to 0, which means there is no vertical shift of the axis of this tangent function. Alright, that's a discussion about how to determine mainly the period and also some other characteristics of tangent and cotangent functions. Thank you so much.